we need about half a minute. So let me share the screen. Hello, everyone. We will be getting started shortly. So Nalini, can you confirm that my screen is visible to you?
Yes, I'm just waiting for it to come up full screen.
Sure.
Okay, perfect.
Yep, I think we are ready to start. It's exactly the time. Over to you, Nalini.
Thanks so much, Mohit. So welcome to our last day of Connections 2022. It's been just a great conference so far. I am Nalini Elkins. I am the president of Industry Network Technology Council, and I am on the advisory board of IETF as well. Next foil, please. So today we're going to talk about standards organizations other than the IETF. For the past few years, we have focused, as far as INTC and IETF, particularly on the IETF, because clearly those particular layers of the protocol stack are where most of us do our work and our thoughts. But there are a number of other layers and organizations that affect what we do in terms of both deployment at enterprise networks and for those of us who are protocol developers in terms of our products and the protocols we are designing. And today, Barbara Stark is going to discuss, she'll lead this whole track. And I will go ahead and introduce her, and then she will go ahead and run the rest of the day. And we've got some wonderful presentations coming up. Next 12, please. I'm going to let Barbara talk about the presenters as they happen. But first, let me thank our sponsors. We have some new ones this time. Cisco and APNIC Foundation, and we have ongoing sponsors who have sponsored us year after year. And so thank you to everyone for jumping in and also for being such a support throughout. It's not just the financial support that keeps us going, but your belief in us that really helps us. So thank you so much. Next one. And to the participants, we want this to be interactive. Use the Zoom Q&A and panelists will come through and they may answer as well. And we do look at all questions and try to get to them as much as we can. Sometimes I know things get a little hectic and questions get left. Please feel free to use the Zoom chat to chat amongst yourselves. And there have been some very interesting chats in the past days. And we do have a prize for the best question of the day. We'll make a donation to their recommended charity. And there's a lot of charities that need a little help from you. So, let's see if we can get a good answer. So next one, please. So let me introduce Barb and turn it over to her. Barbara is she's one of the co-founders and of on the founding board of INTC, and I am going to say that I'm humbled and proud to call her my friend. She has she's just one of the people that I think really typifies the kind of the best at the IETF. The IETF has some of the smartest people in the world, and such as Barbara, but on the other hand, some of the most decent and kind people in the world. And that's why I say is I'm so happy to be working with her. You can see all the acronyms and all the work that she has done through the years. She has recently retired from AT&T, and she has won many, many awards, including Woman in Telecommunications in 2019. Everything is richly deserved as far as she's concerned. She brings a wealth of knowledge in standards organizations other than the IETF, and that's what we want to hear about today. So thank you so much, Barb, and over to you.
Yeah, so
okay.
I'll stop sharing the screen, and there you go, Barbara. Yep.
Okay, so I assume that yep meant I see your slides. Let me get some control here.
We can see the screen. We can see it. Yes.
Okay, so I'm going to be talking about standards bodies, and I'm going to try to focus this on sort of the enterprise, not just standards activities in the abstract, but standards activities as it relates to things that are really interesting for enterprise networks. Hopefully the slide advanced. So some of the things I want to talk about are, what standards efforts exist out there that can actually be useful to enterprise networks, but not just useful if they happened and you let them happen and then they're useful, but maybe this is something that is really only useful if you educate yourself about it, or maybe it would be useful if there were some better input as to enterprise use cases and things like that. We heard yesterday in the presentation that some people from a startup in India went to the IETF and presented their use cases, and thereby were able to make the standards more useful to them. Now there's another class of standards, and that's, there's some things that are out there that are disruptive and possibly harmful. We heard from Paul Vixie all about the things that keep him up at night, and quite honestly, a lot of the things he listed keep me up at night as well. And you can either choose to say, well, I can't do anything about it, they're going to do whatever they want to do, or maybe you can actually try to influence or mitigate the disruption or the harm, or educate yourself enough to mitigate the disruption. So then I want to, specifically look at, what sorts of things could benefit from input as to making them more useful, and what sorts of things could actually perhaps benefit from enterprise input in order to mitigate them, and where might you go to mitigate them. For example, and we'll get into this, while some of the things that IETF is doing around encrypting all traffic and making it so that all networks are there solely for the end users and the network managers have zero input or control, maybe there are things that can be done, but maybe the IETF isn't the right place to do that. And that's something we can discuss. Okay, so let's start with the good part, the potentially useful ones. And I kind of have a couple of slides, at the physical layer, because enterprise networks do have to concern themselves with the physical layer. At IETF, there's not a lot of concern about physical layer, though you did hear a little bit about it some yesterday on the IoT presentations. But there's a lot that goes on in the world of Wi-Fi, and we did hear about, what IEEE does. And IEEE has been busy defining what they call IEEE 802.11be, which Wi-Fi Alliance, of course, in there. And let me just explain a bit of the relationship of Wi-Fi Alliance to IEEE. Wi-Fi Alliance tends to take those IEEE standards and pick and choose which parts they would actually like to certify. And so they take the parts that they agreed to certify, and they're going to call that set Wi-Fi 7 and create a certification program around it for interoperability, and really only for interoperability. And, does it function according to the standard? And by the way, the standard has absolutely no performance metrics in it, as far as I know. And so we will be getting a bit into Wi-Fi performance. And I've highlighted the Wi-Fi performance because one of our presentations today is going to be about testing Wi-Fi performance. Now, going back to the 802.11be and the Wi-Fi Alliance Wi-Fi 7, there has been some discussion about, are there some of the features that may be particularly useful to enterprises? There has been a company, and you can find some of this on the internet, and so I'll say that it is, one of our sponsors, Cisco, who really believes that these two bullet items that I've listed around multi-link operation and what's called restricted TWT, which is simply allocate exclusive use of specific channels, they have been saying that Wi-Fi Alliance should have a test program for this in order to test interoperability, and so that vendors can specifically say, we have this and it's been tested and certified and all of that. Is it useful? I don't know. We have a company that says it's useful, but I don't think enterprises have weighed in, and maybe they should. Maybe they should take a look at these capabilities, educate themselves on that, and and we can talk about how that could happen. As I mentioned, that was one of the later topics. But then there is also, the question of, testing Wi-Fi performance. Wi-Fi Alliance historically did not test performance, and I won't go into the politics of why they refused to test performance, but it is largely about politics. And so what we saw was Broadband Forum ended up picking up the slack on this and creating a test specification and test program around testing Wi-Fi performance. And I mean, let's face it, no matter where you're deploying your Wi-Fi, being able to know that it performs well, you don't want to go buy some expensive access point and find that it only works, with now and then, or in certain ways, or not in the way that you need it to work. And that's why having a performance test program can be really useful in procurement programs. Just some other physical layer things that are going on. This is a bit more peripheral, but G.hn, we see kind of on the IoT connectivity, some things happening there. And again, they do certification programs, and this is something that can be interesting. And there's been some interest in Li-Fi that is using G.hn over light. So wirelessly having signals that don't penetrate walls so that you have it secure and in room. And this can be, you can set it up in meeting rooms where people can have their laptops in the meeting room and they can share, display from their laptops wirelessly, but in a way that isn't detectable outside the room because it's all done over light frequency. We heard yesterday a lot about the 802.15.4. And of course, there's a whole lot of flavors on that. And then we do have a presentation slated today that we hope we haven't seen the slides for it, but we hope it does happen, around 5G. Now, we heard yesterday, somebody saying they didn't think 5G would be that great for an internal IoT network. Clearly, you have a lot of 5G providers who are more than happy to connect anybody's IoT devices to their network, but that's not what this presentation is about, because that's not, that's basically the wireless providers wanting to simply sell access to their 5G network. What's interesting is there have been some proposals for having enterprises operate their own private 5G networks. And that's what one of the talks today is intended to be about. And this can be done using unlicensed spectrum in many cases, depending on national laws and all those sorts of things, which we aren't going to get into. But it's certainly a possibility, and it's something that could be explored and may indeed be of interest to enterprises. So then there's all the things above the physical layer. We heard a lot yesterday on 6LoWPAN that IETF is working on, where it's doing IPv6 for IoT devices. Now you also see, other things around IPv6. You have the operating systems, and what are the features that are going in the operating systems around IPv6? There's been a lot of discussion in some circles around the fact that Android does not support DHCP-v6. And does this impact enterprises? There are some people who think that it may be one of the things that keeps some enterprises from actually deploying IPv6. There are other people who think that that's a red herring. And quite honestly, we don't have enough enterprises weighing in on this to really make a decision. All we really have are individuals saying, I think it does, and other individuals saying, I think it doesn't. And without an actual group of enterprises coming and saying one way or another, we just won't know. We've got sort of onboarding and higher layer connectivity type things that are going on. Again, we heard yesterday about the efforts to do the data modeling called Matter that would be able to model across all sorts of IoT devices and across all the various data model standards that exist. We've seen onboarding from Wi-Fi, Wi-Fi Alliance, because Wi-Fi onboarding has often been difficult, and they're trying to make it more secure, getting away from the old push button mechanisms into mechanisms that allow you to use maybe your smartphones and things like that to assist in onboarding. And I'm not going to go into a lot of these. This is just exemplary of some of the things that are out there that I think are probably of interest to enterprises. Device management, we are going to get a little bit into device management, but as some enterprises are deploying a lot of IoT devices in warehouses, and even small networks, Wi-Fi networks inside their facilities. How to manage those and manage them well is something that is of interest. And again, the advantage of standards is you don't necessarily get locked into a single vendor, and avoiding vendor lock-in can be good, and it can also allow for greater evolvability of your network. And so that's, to me, is why enterprises may want to look at standards-based solutions rather than proprietary solutions for their management. There are also RESTconf and NetConf that IETF created. A lot of the NetConf is more on the, I see a lot of the ISPs moving towards it, and a lot of the big network devices. And so even some of the content service providers and things like that will be using NetConf to manage their huge servers and things like that. But I think Jason will be touching a bit on NetConf and how it differs from some of these other device management. And so even though you have a lot of standards, some of the standards are maybe better suited to some places than others. And then you've got a lot of just sort of network and device and packet security type of things. Some of these we've had some presentations on, some of them may be of interest. And, since Nalini mentioned INTC, of course, if you do have interest in some of these, you may want to mention them to us and we can certainly get some presentations on them. So now looking at some of the potentially disruptive topics, let's face it, IPv6 is disruptive. If it were globally useful and wonderful, everybody would have deployed it. But I think we have to acknowledge that for many people, it's viewed as something disruptive. It's a cost center. It's not an opportunity. It's not something that's going to grow their business if they deploy it. It's something that they have to do. Many of them probably would rather not. I think many are acknowledging that they do will need to go there. But it's disruptive, and we will talk about, what can you do to mitigate some of that. We had a few years ago a lot of discussion around TLS 1.3 and the disruption that it could cause in a lot of financial networks, and the way that they had their customers and such connecting to their financial networks. And I don't know where we are on that, but it was very disruptive. It is, of course, also useful. It is so much more secure than the TLS 1.2. And of course, the fact that it is, and certainly earlier versions of TLS, the fact that it does have greater ability to prevent man-in-the-middle attacks and things like that is useful. And that is why a lot are going to TLS 1.3. But we have to acknowledge the dark side. We heard about oblivious HTTP from Martin Thompson on Wednesday. And certainly, from a privacy aspect, that's great. But that's the privacy of the end device, whether that end device is the employee on the network who is trying to, access their games from the employer network, or whether it's the malware that's trying to call home from inside a network. These are all things whose privacy is also being protected. And so if you listen to Paul Vixie, there is a real existential threat to networks, enterprise networks, home networks, small business networks, from these technologies that are providing absolute privacy to the end devices and the end users on our networks, whether or not that's what we want. So these are some things that we need to be aware of. How can we influence? So just in short, you do need to educate yourself. And webinars like this conference, this whole series of webinars, I'm so glad for the people who've attended, and the INTC webinars that INTC provides. You need to know who your allies are, join with them. Again, that is why we try to have organizations like INTC. That is why Nalini, it was her brainchild. We need to form this so that we can have a place where enterprises can come together. Don't assume someone else will do it for you if you're not willing to put in the effort. And don't assume that the best place is, where the effort is going on, that he's either creating the useful standard or that is creating the harmful standard. IEEE, of course, creates the wireless standards, but that's not actually where the work is done to create the certification. And it is that certification that allows the Wi-Fi standards to be so useful. And so Wi-Fi Alliance is important. And then you have Broadband Forum working to do the performance testing. And so just because IEEE created the 802.11 standards doesn't mean that that's the place where you want to go necessarily in order to get to push the greatest use of their standards. Be creative. And so kind of specifically, in IETF, I do want to give a shout out to the V6 Ops working group. It's a supportive working group that is specifically wanting to understand how can we make IPv6, instead of being disruptive, how can we mitigate the disruption, and how can we make it useful to enterprises? And if we could get the enterprises to actually go there and really engage with these people, and it is free to engage with them, they are supportive. There's no travel required if you don't want to travel. We discussed Wi-Fi. Hopefully we'll have the discussion on 5G. There are some possibilities, and we may want to explore this more with Paul Vixie and maybe with Martin Thompson and see what we can do. We could possibly have some more webinars on this topic. And again, INTC was specifically formed to provide a place where these discussions can happen. Okay, so that was mine. And now I would like to introduce, okay, who did I put next, Jason or Lincoln? I've got to get.
I don't want to throw Lincoln under the bus, but I believe it was Lincoln.
I believe it was me.
Yeah, it's Lincoln, testing Wi-Fi performance.
Okay, then I am going to turn it. Lincoln, Lincoln, I don't have your bio up because I was just presenting. Could you do me a favor and introduce yourself? Look, there's your bio. Senior engineer at UNH IOL. You've been there the entire time I've known you.
I have. I've been with the University of New Hampshire, the Interoperability Lab, for about 20 plus years now. And in that time, I've been focused entirely on working with the communications and technology communities to provide testing and to basically further a lot of the work that's taken place in the Broadband Forum, as well as the Linux Foundation. And a smattering of other forums along the way as we've developed a lot of that testing throughout the years. So let me go ahead and see if we can get this on up to full slide deck. You guys are all hopefully seeing that well now.
Looks good.
Excellent. So first of all, thank you very much for providing the opportunity to talk about this. And I hope you'll forgive me for diving a little bit lower into the physical layer discussions here from the higher pieces and parts that we've been talking about previous in this week. As I mentioned, I've been with the Broadband Forum for a number of years with the University of New Hampshire. I'm currently serving as the technical chair for the Broadband Forum. So I kind of love to call that the herding of the cats to keep everything running in the same direction and hopefully be doing good work for the industry and avoiding doing too much of the disruptive work that Barbara was talking about. And so we're really aiming to collaborate with everybody and develop the specifications that are enabling the best of these technologies to really come out into the field and come into the deployments. So we're talking about Wi-Fi today, and specifically Wi-Fi performance. And where we start from that is the things that kill your experience, right? Because at the end of the day, where this is coming from and where the focus is on the consumers and the users' experience of this, because they're the ones that are driving that expectation. And that those users could be, as coming from the Broadband Forum side of things, subscribers to a broadband service, or they could be enterprise users within the company network or on the company campus or on the wide area campus, for something like a university. It really, it kind of is all the same role and function. And a lot of this has, kind of peaked over the last, I would say, 5 years as Wi-Fi connectivity has become synonymous with basically internet connectivity or network connectivity. If you don't believe me, the easy way to introduce this is, when was the last time that anybody visited a neighbor, a friend, a bar, a restaurant, and you asked if they had internet? That's not the question that is asked. The question is, do you have Wi-Fi and can I get the password? So Wi-Fi has become synonymous with the internet and connectivity experience. And that means overall that it's become synonymous, or the quality of it has become synonymous with how good that network connection is, right? It's how good is the internet, basically. And so we need to drive that customer experience, that quality of experience metric high. And if we miss the target on that, then the end result is usually grumpy users, and from service provider aspect, truck rolls and cost increases as they're trying to support or troubleshoot that bit of the network. Users are expecting this to just work and be seamless in how it works. They're expecting seamless coverage and seamless quality without having to know the technical details of how it works, how their coverage works, or anything like that. And that really comes down to, more than anything else, that quality of the equipment that you're deploying into the field to provide the service. So Barbara mentioned TR-398 a little bit in passing from the Broadband Forum, and kind of in a nutshell of like, what does that actually mean? It's essentially a set of performance tests that have been defined by the industry to evaluate the capabilities and performance of an AP. And specifically, or more specifically, It's defining that test methodology in a way that allows for essentially repeatability between test runs, between different labs, and between different devices or revisions of software or firmware on those devices. And the whole goal of that is essentially that you need to be able to do that apples to apples comparison when you're looking at how well a device is performing, right? Because this isn't about doing it a one-time off or something like that. This is also about like future-proofing my network of like, if I'm looking at how the next set of devices that I'm rolling out or the next firmware or software revision that I'm rolling out into the network that I'm managing is going to perform compared to the past one. And if your setup, if your environment is constantly changing, if it's not well enough defined, you can't get that apples to apples comparison that is, necessary to support that activity. From the perspective of the coverage, Barbara mentioned a lot of focus on pulling in or having discussion with the end users or the enterprises of this. And that's exactly what the Broadband Forum has done in the development of these activities. So the focus hasn't been on, let me look at the specification and come up with something that's very academic. It's been very focused on what are the carrier requirements for this to actually be able to call something a carrier grade Wi-Fi solution. And that kind of translates into a couple of key focus areas, obviously, kind of highlighted there on the right, where it stems and starts from, some of the aspects and stuff that you would see for like RF performance and things that you would expect for Wi-Fi like coverage and capacity. But then you also get into those other aspects like stability and robustness, where it's, needs to be measured that such that the device is actually going to operate in the long run. It's not going to, operate for 6 hours and then fall over and need a reboot, or, not be able to pass high rates of traffic over long periods of time because, there's, a stability error somewhere in the device or the firmware of that device. The other aspect that's great about this testing is that through that cooperation with the industry, we've been able to develop the pass-fail metrics in a way that are actually absolute bars. And so what that means is the end result from all of that work is that when we're testing an access point device for one of the technologies, the end result of that testing and that test plan is, does it pass or does it fail according to what all of the group in the Broadband Forum that came together to do that definition has said is good performance or poor performance. And so, thinking about like the political discussions that go on that is obviously a political topic, because anytime you're worried about, bringing together, differing views on the topic of what is good or what is bad, you're going to get those discussions. But I think that's one of the points the Broadband Forum has done very well over the number of years that it's been doing these type of projects of really, seeking out that common ground position on what that means for performance and setting those metrics so that we can actually have something that becomes a useful test plan to everybody that's looking at the outcome. If we were to look at like some kind of diving down into it a little bit, I think that, from the existing Wi-Fi testing and a lot of activities that are going on, TR-398 really does complement that aspect, right? Like TR-398 is not trying to redo regulatory testing or functional interoperability testing or grouping of 802.11 features together. Again, it's been very focused on defining performance and performance metrics based on that carrier grade need from the Broadband Forum service provider and operator communities to actually make sure that these devices are delivering essentially on the promises of the technology when things are being deployed. And so from that aspect, the coverage, the performance, capacity, stability, interference, kind of categories of testing really do provide a good measure of how well those AP devices actually, perform, in delivering wireless Wi-Fi based services to the stations out into the network. So if we switch gears a little bit, just to kind of think about like, how do you actually approach doing something about this, right? And we talk about the test environment, really it comes down to repeatability is key. And to get that repeatability, you basically need, the rest of kind of some of these parts and pieces. We need to create a clean environment, a clean air environment, where you don't have interfering signals from the rest of the world in the middle of your testing. If you are in any type of a populated area, that's nearly impossible to get in the open air or open world. You really do need specialized equipment to kind of control that path. The second piece is that controlled RF path, right? So that, if we're going to measure how well a wireless device does in connecting, between an endpoint or a station and the access point, we need to be able to control that path in a way that is controllable and repeatable. And then we need to be able to control the devices that we're using for the testing. So in the case of BBF 398, where we're testing the access point, we need to control the stations so that we can lock them down to specific operating modes, so we can actually test things in, again, that reliable, repeatable, controlled fashion. And we're going to instrument all of that traffic throughout that process. And so kind of taking from these key aspects of what is a test environment or how do we do this, we can look at like how we've chosen at the Interop Lab to implement something like this, working with our partner Octoscope. Essentially, we have multiple RF isolation chambers that then have coupling together for things like programmable attenuators that control that emulated distance from one of the devices to the other device. From there, we're able to then use things like emulated stations, where again, we get that instrumented station to have the detailed control, to be able to force it to perform in specific actions, specific ways. And then lastly, we roll that all up through an automated system so that essentially we remove the human aspect of it. So we, most importantly, that kind of controls the timing aspects of something. So if you're measuring a 1 or a 2 minute or 10-minute or 8-hour test run, it's exactly that every single time. And you're not really worried about the human pushing the button at the right time, because the computers and the machines are far better at that for us. So where is all this going, and where does this go? So, we launched the completed test plan within the broadband forum about a year ago now. From there, it took a few months to get the first products awarded the badge, so that the vendors of those products were going through and actually doing the testing, improving their outcomes, to the point where they were meeting the requirements of the program. We'll talk about the requirements of the program in just a minute in some more detail. From there, now we're really moving on, and we're continuing to evolve the technology, because one thing that is, true in everything that we've talked about so far is nothing stops and nothing stands still. And, the technology is going to continue to evolve. So things like Wi-Fi 7 are going to come out. Deployment scenarios and use cases from the operator community are going to change. And the program, to continue to be useful to everyone, needs to evolve with those things, to continue delivering on the promise of what does it mean to have high quality or high performance Wi-Fi. So within that program, the end goal is essentially to make something that's very useful to procurement offices, to be able to know that things are meeting the bar of the expectation of something that's highly performant. And so the product is tested by an approved laboratory according to the approved specifications. The report indicates that you're passing the mandatory test cases that, again, the industry and group have decided and defined what are those mandatories. And then the manufacturer is the member of the broadband forum, just in terms of pulling that marketing benefit and being on the website there, listing. And the important part of that is all those listings are available on the BBF website. So it essentially creates a resource for the industry to go out and seek what is meeting the expectations on performance versus not. There are 2 approved labs. I'm glad to say that the University of New Hampshire Interoperability Lab is one of the labs. Allian in Taiwan is the other approved lab. So both these labs have done a lot of work with the forum to make sure that we're meeting the expectations of the test plan, and that the results are repeatable and comparable between the 2 organizations. And then, looking over that horizon of where things are going from next and where they're going from here, as I mentioned, we're going for that, what we would call issue 3 within the broadband forum, and then we're expanding that testing coverage. One of the big features and key points is getting better coverage for the mesh and roaming scenarios, catching up on the newer technologies. So things like adding the 6 gigahertz channels that are sometimes called Wi-Fi 6E, things like higher spatial stream counts or OFDMA aspects, and actually measuring that. And then lastly, looking at some other metrics beyond just, pure throughput and stuff like, or packet loss, things like latency and jitter, as those aspects of the network are going to become increasingly critical for things like, augmented reality, virtual reality, deliverance on kind of those sensitive or high experience, high touch, high connectivity requirement applications from there. And all of that work is going to continue focusing on essentially quality of experience for the subscriber or the end user. And it's going to continue with the absolute metrics, requirements that are being developed by the community. Again, pulling in the use cases, the conversation from the operators, the vendors, and the enterprises of what it means to actually be a highly performant device on these devices on Wi-Fi, so that again, that pass-fail coverage that can come out has that meaning and that metric. So that's everything I had on the Wi-Fi testing today. Let me know if there's questions. I'm happy to dig into any of the topics in kind of some more detail as well.
So if you do have questions, feel free to write them. I'm looking at chat, I'm looking at Q&A, and I'm also looking for hands raised. I do have some questions for you, Lincoln. So of course, you mentioned that TR-398 was developed for carrier grade with input from the internet service providers. Do you think that this performance test specification would also be useful for people like in a university planning their university Wi-Fi or a campus Wi-Fi?
Yeah, no, I absolutely think that it was useful beyond just like a broadband telecom service provider. Like at the end of the day, what does a device connecting to Wi-Fi in terms of high performance mean? The way you're going to evaluate that access point is very much the same, whether it's an access point provided by, a service provider or telecom provider, or it's an access point provided by the IT department and deployed onto the campus. The testing approach and the methodology is going to be nearly identical.
And how would you suggest that maybe an enterprise ask for TR-398 certification?
So you can just definitely put it directly into your RFI, RFQ documentation in citing the technology and the testing specifically. If you're not doing that, educating your department on your purchasing department on where to look for devices that have already achieved that, or to verify tenders have actually achieved it and they're not just ticking boxes. In looking at the web listings that are available from the broadband forum. And then, lastly, there's always the possibility to have the conversation with one of the testing labs to engage kind of on that direct front if you're interested in testing specific products.
So I see Nalini's hand is raised.
Yeah, no, this is very, very exciting. If somebody else wants to talk, because I don't want to, I can go on forever. But one of the things, and this it intersects a little bit with what Barbara was talking about, is well, there's two different topics really. Which one is with jitter and everything else, you're creeping over into my favorite area, which is diagnostics, and so that's something that I feel has really been not covered at all well in terms of the IETF and how we do it. To cut a long story short, what happens is people develop all these standards, whatever layer they are, and then people implement them. And a lot of us on the line right here are kind of like, okay, it just failed. How do I make it, bring it back up? And what? There's no diagnostics possible? And there we go. And so there's a couple of things, and we should probably take this offline if you guys, and maybe Justin as well, if you guys have interest. I'd love to see a diagnostics area, and also maybe some of the other layers and how, but I don't even know. I don't know, it's like you guys have your hands full. I don't know if INTC wants to come out with layer 3 certification. I don't know. You know what I mean? It's like, as I say, I'm gonna mute myself now and let you get a word in.
So before Jason has already said that he is going to cover some details about diagnostics. And so that's a perfect lead-in into Jason's presentation, but we're not quite ready because we do still have some, I think, some time slotted to discuss some of the Wi-Fi performance. But absolutely keep that in mind as you listen to what Jason is talking about, because he is actually going to talk some about managing the Wi-Fi network. One thing I did want to mention, by the way, since we've had a lot about IPv6, you know, just in case anybody likes to put pieces of a puzzle together, UNH-IOL is also, I believe, the organization that does the IPv6 ready certifications. And so that is another one of the programs that goes on there. And that is also something that enterprises may be interested in. And I think they've been doing some work with the US government, I believe, to actually do some certifications along the lines of US government requirements as it relates to IPv6, but IPv6 is not your thing, Lincoln. But
I can talk just enough to be dangerous about it. But yeah, the US government collaborated closely through NIST, the National Standards Organization piece, just to pull some of the, you know, I would say similar to Wi-Fi Alliance, to pull kind of like the best pieces from the Ready logo out and cite a profile that they then require equipment to meet in terms of IPv6 readiness, because the goal there is really looking towards the future of you know, trying to lower or lessen the, you know, disruptiveness of adding the technology in the future by having the network on a longer story arc, you know, incorporating equipment that's already known to implement and support it, you know, even if it's not fully rolled out and deployed, you know, everywhere across the board. And so that's been going for, you know, a long number of years now. And I think it's actually, if you look at the IPv6 adoption in the US networks, at least, you know, I think it's actually been, you know, a good strategy to kind of get things ready out in the world.
Mike?
Thank you, Barbara. And thank you, Lincoln. This is really great and interesting stuff. My question is from a dumb enterprise point of view. Should we be excited about Wi-Fi 7? And I have a feeling your answer is going to be yes. So my real question is there like a top 3 drivers that should drive our interest or anything along those lines?
Well, I mean, I think Wi-Fi 7 is pulling in a lot of the, you know, kind of lessons learned from like Wi-Fi 6, you know, and some of the improvements you're going to see on like how they've done the OFDMA aspects, like how you're, you know, dealing with, you know, really increasing numbers of stations that are coming onto the network, you know, and the stations that are going to be consuming either fractional or smaller parts of the bandwidth, you know, upstream. And so, you know, that's going to really make it necessary for things like, you know, that rollout of, you know, the crushing wave or the wave of IoT devices that may be, you know, coming onto the networks in the future and consuming service and time, but not necessarily all of like that AVR, you know, high bandwidth application. Those are going to exist. They're just not going to exist in the quantities of the smaller devices. And so what you really need to do is be able to have a technology that's going to balance kind of both of those pieces at the same time. And I think that's where you're going to see the Wi-Fi 7 really kind of have that opportunity.
Okay, so the support of more stations, more addresses, is better performance going to be a driver there too? Yeah,
I mean, the performance is going to continue to go up in the Wi-Fi scenarios. You know, it's gone up with every new release of the IEEE specifications, you know, as they've come out. You know, that's a function of a, you know, almost similar to Moore's law in terms of just being able to do more advanced coding, you know, more advanced modulation schemes, you know, adding things like feedback loops and stuff like that to support like MU-MIMO technologies that are out there and stuff. And so each time you rev the technology, you have the opportunity to basically take advantage of the state of the art of what you can put on an ASIC, which drives, you know, really that increase in performance.
That's awesome information. Barbara, can I sneak in one more question?
Of course, Michael.
Okay, try to stop me, right? So what I'm wondering is, Have you done any comparison testing about how IPv4 versus IPv6 behaves over Wi-Fi networks?
I actually have not done any like apples to apples type comparison on that front. So I don't have kind of a good set of information that I could pull from there, unfortunately. So
That's fair and fine. Again, thank you for an excellent presentation. Appreciate it.
And so I see a question from Kosi Amesino. I don't fully understand the question. I don't know, Kosi, if you're able to come off mute, but your question was, is it possible to use Wi-Fi 6 technology in power countries? Perhaps, I think the question I would have is, what is a power country?
I wonder if it's is countries which have power issues. Yeah, I don't know. Maybe the questioner can come off of mute.
So I can make a guesstimate of the question, maybe too, of one. So one of the things that everybody kind of conflates a little bit between the Wi-Fi terms is Wi-Fi 6 to 6 gigahertz. So Wi-Fi 6, and this, we have the WFA to thank for kind of the marketing bits of this. Wi-Fi 6 by itself is referring to 802.11ac, or sorry, AX as a technology. And that's pulling in, that rev of the IEEE specifications that added newer modulation techniques and the ability to do things like OFDMA to address some of the upstream issues. They did also define a mechanism or the standard approach to then extend and utilize the 6 gigahertz frequency. And so the Wi-Fi Alliance kind of broke that off to call it 6E. And so you can actually use 802.11ax in 5 gigahertz and fall completely within the current regulatory domains of most countries, even if the 6 gigahertz spectrum hasn't yet been opened up, in your country. And apologies if that's not what the question was overall.
So I have allowed the mic to be open for the person who asked the question. So Kosi, maybe you want to unmute and go ahead.
I'm talking about the power country. We have a country where we don't have electricity. We don't know without electricity if Wi-Fi 6 technology are being easily be used. If not, why can it can be very important for us to move to that kind of technology when we don't have electricity, we don't have water for our specific use. That is my question.
So go ahead, Barbara.
Well, I was going to suggest that it sounds like maybe what's needed would be to understand the power utilization, perhaps, of some of this technology, because if you're in an area that doesn't have a lot of electricity infrastructure, perhaps there's the ability to use solar power to power things. Clearly, things have to be powered. But if you don't have a lot of electricity, are there any tests in TR 398 that can test power utilization?
So 398 specifically by itself didn't really focus on the power utilization aspects of it. I would say that, if you're looking at like Wi-Fi utilization from something like a solar system or something like that, that's probably going to be, a pretty specific engineering, effort to really kind of go in the thing, and not so much from Wi-Fi, but like anytime you're operating a transceiver or a transmitter, of any technology, those things tend to be power hungry systems. And so then you start looking into power saving modes, shutting down the transceivers as much as possible, having, either specific timing slots that things are utilizing and stuff like that. And so there's a lot of aspects that you can kind of pull together to make something as power efficient as possible. But that hasn't necessarily been the focus, of like 398, because some of those things start to brush up directly up against, what does it mean to be, the highest possible peak performing, which the trade-off there is sometimes burning some power.
So it sounds like in the short answer to Kosi's question is no, that has not been looked at in the context of TR-398. But that does bring the broader question of, kind of where I was looking at things of getting more input into standards. I mean, a lot of the standards activities, if we forgive the political digression, but we recognize that it has been highly dominated by North America and by Europe, and by a lot of the parts of society that don't properly understand the use case, Kosi, that I think you're bringing up. And somehow I think it would be really, really helpful if we could have people like you who do have an understanding of these use cases to bring in requirements and use case and increase the understanding of the people writing specifications so that they can address these use cases. Did that answer your question at all? Okay. So are there any other questions for Lincoln at this time? If not, I realize we are running just a little bit early, about 10 minutes early, but I think we can go ahead and start into Jason. And so I am going to see if I can introduce.
I will open
Yes.
the bio. Yeah.
Yes, please. Thank you.
Sure.
I've also known Jason for a long time, by the way. He's also up there in New Hampshire, but he left UNHIOL to go to another company, QA Cafe, which also does a lot of testing, but some different kinds of testing. And as you can see from Jason's biography there, he has been involved in broadband form for quite a while. He's been involved in the predecessor to the TR-369 USB, which is what he'll be primarily talking about today. The predecessor was TR-69. And the goal really here is about device management. So if you look at things like SNMP and NetConf, and what those were targeting, and Jason will go into this, so I don't want to steal his thunder, but they were looking a lot more at network elements. But as Nalini pointed out, as we get more interconnected, we really want to understand, be able to manage and also understand the performance and diagnose sort of the network as a whole. So I'm actually going to now let Jason launch into this, which is one of the dearest and nearest topics to my heart. So have at it, Jason.
It's like it's its own beast. Hi, everyone. I am Jason Walls, as Barbara said. I'm the Director of Technical Marketing at QA Cafe. We make a number of test and analysis products. The one that is usually the most relevant is our CD router test product that we use to test mostly gateways, but the enterprise gateways too. It's the test platform that exists for the protocol that I'm going to be talking about, which is why I'm so deeply involved in it, other than having been involved in broadband forum for so long. Okay, so I wanted to set the stage by talking about SNMP and NetConf first, because I think that that's what most people who are involved in enterprise networking and the IETF in particular are familiar with, but also to sort of set it in contrast to what I'm going to be talking about in terms of device management from not necessarily just consumer networking devices, but as you get closer to that, is where the use cases start to change a little bit. So if you're familiar with SNMP and NetConf, SNMP is old. It was way back in the day. It was kind of the original thing that people were using to manage. When I say manage, I mean, configuring, getting alarm information from, and getting and monitoring data and diagnostics, like Nalini was talking about, from networking gear, from routers and switches and all that sort of stuff. And that evolved into what we know as NetConf today, or RESTConf if it's using the RESTful HTTP methods of doing that stuff. But for the most part, it's NetConf. There were the concept of something called a data model, which I'll be talking about a lot today, which is a description of the capabilities and metrics of a device. And those you try to standardize those. So under SNMP, it was called a MIB, or a management information base. There was an entire branch of the MIB called private, which allowed people to sort of just define their own, and that was used a lot. if anybody remembers, that ended up kind of taking over, even though a lot of the other parts of the MIB for different technologies was well standardized. But the IETF has moved that to Yang, and those things are becoming pretty well standardized. So like I said, those things are well known to IETF, but the methodology behind NetConf, because it is developed for these more permanent, larger systems that have very specific use cases, it's built kind of around a push and apply. So it's like you're delivering the entire state to the device and saying, okay, now do this. You can, which is in contrast to what I'm going to be talking about in a minute. It's built to be able to read data and do diagnostics. The messaging in NetConf is XML based. There is some JSON support, and obviously, it runs over TCP, which we will run into the reason why that's important in a minute. Things change the closer you get to consumer networking, whether that's, and it starts to cross the barrier into the enterprise world, because some of these things are literally products that you would be using, in a business scenario, or things that employees are using and bringing, and bringing to the office, BYOD, or in the new world of everybody working from home, the things that you literally have to deal with because your employees are engaging with you as an enterprise and doing the work that you need them to do, but they, you need them to be under the jurisdiction of the same requirements that they would have if they were in the office. So, it's security systems, IoT stuff, user devices, phones, and laptops and stuff. And the weird bridge where this all meets is at Wi-Fi, which is, it's also kind of the most important topic nowadays. So feel free to ask any questions about that as I'm going along. It is certainly the biggest pain point at now, and the things that we've been working on at the Broadband Forum has been, specifically with USP, has been to help sort of solve this and standardize this. But I always think of, Wi-Fi access points and mesh systems are kind of this weird unification of enterprise and consumer networking devices, because a lot of the Wi-Fi access points that we're deploying right now, the companies that are making them, they have them almost like it's a scale in terms of which of their products apply to which use cases. But on the surface, their cloud applications that are managing these things are all the same. So whether you're an enterprise or a small business or a home user, you're all engaging it the same way. Device management has different needs. So you need the protocols, and the use case for device management means that you want it to be done in real time. Sometimes the config has to be done incrementally, right? You're changing one thing rather than being like, okay, I'm now going to push a big config update to this device and leave it at that for a while. There's the onboarding and bootstrapping scenarios that you need to manage. There's lifecycle management itself, and that includes firmware, but also individual software modules, which is something that USB does. You also have a situation where, unlike larger enterprise networking devices, these things aren't going to be on all the time. They might go away. They might go to sleep. They might move networks. They might come back later. And then also, in the consumer space, you're crossing network boundaries like NAT, where you can't necessarily have a two-way communication unless you have some other communications technology that's helping you out. So when we talk about the user services platform meeting all these needs, we talk about it as a system of controllers and agents that enables remote manipulation of software and hardware capabilities. That is like the highest level definition of USB that I can possibly give. And we came up with this statement to sort of put it in contrast with the evolution of TR69, which I want to talk about really quick. So this all came from TR69. If you're not familiar with TR69, it was developed back in 2004 because a bunch of operators were relying on local methods of, trying to reduce truck rolls and getting users onboarded with their home gateways that were being shipped to them. Sometimes they used to ship like a CD-ROM and have them run it locally to get everything up and running to kind of a basic configuration. They didn't want to do that anymore, and they wanted to be able to do lifecycle management and monitoring provisioning. So they made TR69. The TR69, I'll go into the differences in a minute. But over time, it got very quickly picked up and expanded into a number of further use cases for different kinds of CPE, right? So set-top boxes and VoIP devices, and then eventually Wi-Fi. And so, this initially came from the telco world, and then the cable and MSO world picked it up and expanded that use from a Wi-Fi perspective. And then between 2010 and when we decided to develop USP, there was basically this explosion of new devices, and we saw the message on the wall saying, it's time to break open TR69, build on everything we've learned, and build a new protocol. And the most recent version of USB is 1.2, coupled with the data model that's defined in a document called TR181 that I'll talk about in a minute, device 215. And that was released at the beginning of this year. So a little bit of that history on TR69. So it was done with SOAP over HTTP to make remote procedure calls, which has its advantages. It allowed it to be standardized. It allowed it to be, kind of well understood by web service systems at the time. It's built so that there was a kind of a single relationship between an auto configuration server and a device that's being managed. So a device is only ever talking to one ACS, we call them, at a time. In order to, and that communication was, was always triggered by the endpoint, the agent, the CPE. So the CPE was always the first one to talk, and that's how we got around the NAT problem. However, there was a mechanism to try to get the ACS to kick the device to talk to it, called connection request, and that did run into the NAT problem. We later expanded the connection request mechanism to operate over XMPP, which, and it meant you were deploying XMPP only to do this connection request mechanism, but it's in there, and it, kind of solved that problem. The RPCs for TR69 were defined in a schema, so it was well understood. Then there was a legacy data model that was kind of defined at first. It was very much based on UP and PDM. But then we moved that to TR181 device 2 later on, which is less hierarchical. It was actually a lot more in line with the way that SNMP used to do things in terms of interface stack and stuff like that. And then the other kind of caveat to TR69 is that the northbound interface to an ACS was never really standardized. It was always sort of deployed. It was built and deployed in a manner that the operator wanted and the ACS vendor provided. Now that's a little different because especially for the enterprise use cases, people want to be able to plug those systems into a cloud native system and have a RESTful API there. But, despite all these caveats, it was super successful, and there's over 1 billion TR69 deployments today. So we moved on to USP, and we said, all right, what are the things that we need? Based on what we learned, what are the things that we need to do to change the technology a little bit? And the fundamental thing was breaking open that idea of a single controller or a single ACS talking to the agent. And so the USP's biggest advantage is that you have multiple controllers talking to something that can be managed, and all of those controllers can have different roles and different permissions and be built for different reasons and interacting with different applications. To facilitate that, we developed a kind of another layer of security that allows messages to be communicated securely encrypted and with integrity between two endpoints, regardless of the proxies or message brokers that are in between. We allowed, we made it so that if you had to define a new RPC, you didn't have to do it in the protocol itself anymore. Because there are multiple ways of communicating with a device with different use cases, there's not necessarily a cloud dependency, which is a big advantage in comparison to a lot of for Wi-Fi management in particular, a lot of the solutions that are out there right now that are kind of optimizing based on the assumption that it's going to pass a lot of information to some cloud service is not necessary with USP. We also built it to coexist with TR69 so that operators could have a clear path forward and not worry that we built something new that was going to break everything. There's a proxy mechanism, which is especially important in like the IoT space. So, devices can, you can build a system that can communicate with devices that don't speak USP and then have it appear to a USP controller as if it did speak USP. And then we standardize that northbound API so that a controller can more easily fit in a cloud native environment. And I like to think that we put a very clear distinction between layers. And as you'll see, the joke is with USP that, now we're talking about layer 9 because, there's all these interim things to make sure that things work correctly. Biggest difference between TR69 and USP, I love this graphic that one of our developers put together, is it's much less chatty, right? So it's based on newer communication technology. So you don't have to go through this entire process just to set a configuration or get some data. It's an always on connection that will give you immediately what you're looking for. I like this slide because it kind of explains the pieces that we've built in terms of standardization and how it all works together. And we like to say that good technology has this sort of triangle of standards, testing, and open source. So the standards that define USP are TR369. That's the main standard. I'll explain what's in that in a minute, along with the data model that works with it, which is TR181 issue 2, currently in version 15. All of this stuff can be found at usp.technology. And then we also back that up with an official broadband forum open source solution for the agent side as a reference that allows vendors and or anyone implementing it to use it as a reference to build their own implementation. And then we have a certification program that goes along with it. So, someone comes along, they can use OBUSP agent to start building what they need. They program all of the hooks that are necessary to manage their device, and then we run it through testing and certification to get a certified device. So keep this slide in mind as I go forward, because it kind of explains the way that everything works together. So you can see multiple controllers fulfilling different roles here. There's trust establishment between agents and controllers to make sure that role-based access control works, and that access to different objects and parameters is locked down to only the people who need them. And then also that flexible transport mechanisms. So we have a couple defined that I'll go into for different use cases, but it allows this entire ecosystem to work together. So it is entirely realistic that a user could have a USB controller on their mobile device that can talk to USB enabled devices. It's entirely plausible that you have a third-party vendor that is building an application that let's say managed Wi-Fi or some other kind of network optimization. These companies already exist. They're building USB solutions that somebody can come and be like, oh, just buy this off the shelf solution that's going to do this for me. And because it's standardized, it's going to work with the equipment that is deployed that supports USB. And then we also have some other out of bound mechanisms for bulk data collection that I'll talk about in a minute. But this is the overall picture. And then the TR181 data model is built for all of these different use cases, right? The ones here at the top are kind of the ones that were the original use cases for modeling in the first place. And as you go down, we added more and more and more functionality. This is the protocol stack. This on the left, you kind of see a diagram of how the different endpoints work together and their internal components. You see the optional REST API at the top here, but ultimately, you have multiple controllers. you have it coexisting with the older TR69 ACS if you want to, and then these independent data collectors if you're using the bulk data collection mechanism. This is the protocol stack on the side. You can see that it's kind of, it's definitely many layers in one, but we have a standard set of messages. We use protocol buffers to define them. They get encapsulated in a USB record, optionally sent over an application layer TLS connection, and so on and so forth. You can see these message transfer protocols, we call them MTPs to not get confused with the actual transport layer, are defined we have these three for a number of different reasons that I'll go through in a minute. The things that I'm going to talk about next, though, are so we call the things that you can manage, we call them service elements. And then there are two different kinds of data model, right? So there's the supported data model, which are the things that it can support, and the instantiated data model, which is the current state of the device. The USP spec itself, this is what it covers. You know, it has the general architecture and how you're supposed to work with and address the service elements defined in the data model. It provides mechanisms for endpoints to discover each other, either over MDNS or DHCP, or you know, statically, and also in those brokered message transport situations. We cover those message transfer protocols and how you bind USB to each of them, and so if there's any special rules that are required, they're defined in there. We define the message encoding, which is literally just protocol buffers, which is nice. And we define how you do that end-to-end message exchange with a USB record, whether or not you are doing it in a, we call it a session context, or just, you know, or without that session context. We define all the messages and how they work, how controllers and agents authenticate to each other and authorize certain permissions. And then we go into a bunch of theories of operation for the different use cases that are enabled by USP plus the data model. So what is a service element? They are basically objects that are defined and that contain parameters. They contain parameters, events, and commands, and those are all defined in the data model. And those service elements might be allow you to build a Wi-Fi configuration, do performance diagnostics, do smart home functions, do firmware lifecycle management, like I said before. But that's what a service element basically is. And you address those service elements using an object path, and that's defined in TR 369, but it works, it's defined in the context of TR 181. So you have ways of addressing an object directly, addressing the instance of an object if it's, you know, if it's a table, addressing a parameter, a command, or an event. You can address them by the instance ID, or you can use unique keys. And also the nice thing about this is it allows for search paths. So you can have a controller reach out and say, give me everything where the error count is higher than 1,000, and then the agent will report that. Like I say, so service elements are all defined in the TR 181 device 2 data model. The data model itself is defined in XML according to a schema that's defined in TR 106, but obviously over the wire, we don't use XML anymore, even though we did with TR 69. We reused the data model as much as possible so that a device that supports TR 69 and USB can work together with both systems. And that defines some common components, but there are some differences, and the differences are really those objects and parameters that are relevant to the operation of the protocols themselves, right? So there's some things that USB doesn't need to know, and there's things that TR 69 doesn't need to know about USB, and vice versa. And USP, because it allows for the data model definition of commands and events, we moved a lot of the functionality that is defined in TR 69 into the data model, because that's where it's handled by USP now. It also allows for vendor extensions, right? So I was talking about the private tree of the SNMP. So it does allow for vendor extensions, and those are used in the industry, but we update the data model very frequently, like on the order of 6 to 9 months. So anytime somebody has a really good use case or wants to change something, we have a good process for making sure that gets up defined and standardized. There, just as an FYI, there has been some work, it's still in progress, on being able to take a TR 181 data model and translate it into Yang. which can be really useful in the future when we're talking about those northbound interface situations where you want everything to work together. I want to come back to this because I'm going to talk about supported versus instantiated data model. So we differentiate these things because there are two different ways that you can gather them, which is another benefit of USP over tier 69, is that tier 69 didn't have a really good way of discovering the capabilities of device. And so, we define supported data model defines which service elements you can understand, right? The ones that you could support if you wanted to. And you can retrieve that with a message we call get supported DM, which is very convenient because a controller can come on board, an agent will connect, and the controller can be like, tell me everything, tell me what you do. And it's very granular. And it's also based in the context of the permissions of the controller. So if the controller doesn't have permission to do something, generally, we don't even tell that controller that certain functionality even exists. Then there's the instantiated model, which is the device's current state, right? And you get that with, the traditional messages that you're thinking of. So get, which returns the information about the objects, and then get instances, which is basically like, here's a table, here's a multi-instance object. Just tell me the unique keys and the instances that exist already. And all this sets up for that role-based access control that we put into the protocol. So it defines what a controller can and can't do. It's something that we built as sort of a key differentiator from tier 69 and a lot of other protocols, right? So because protocols don't have this multi-controller architecture, it's not necessary. But because USP does, and because it has that power, we had to put role-based access control in there. So controllers will have different read, write, and execute access on a very granular basis. So it's down to the parameter if you need to. And it ties in with the authentication authorization mechanism. So when an agent adds a controller to itself, it'll assign that controller a role based on what it knows about it, and then go from there. Let's talk about those message transfer protocols. I hate coming up with new acronyms unless it's absolutely necessary, but it was in this case because we wanted to differentiate from the term transport, because a lot of times people say HTTP as a transport, right? But it's not literally layer 4. So that can be confusing to a lot of people. So we came up with this new title. There's 3 available in USP, MQTT, Stomp, and WebSocket. MQTT and Stomp are both like message broker protocols, right? So they're built to send a message to a server and then have the server send that message to somebody else based on certain subscription parameters. The reason why there's 2 of them is because we had originally defined CoAP, Stomp, and WebSocket. We got rid of CoAP in 1.2 because it wasn't really used in the way that we wanted to use it. And a lot of operators were already deploying MQTT to manage a lot of other things, and smart home and IoT situations. So a lot of that infrastructure was already out there, so there was demand to add MQTT to that list. And Stomp, you might not have heard of Stomp, but it operates very similarly to MQTT. And then WebSockets are WebSockets, obviously, and we wanted that for those legacy situations where you have a gateway, you want a communication channel nailed up that's going to allow you to do that instantaneous communication. But you want it to be point to point. And that the WebSocket is kind of the use case that we used to replace CoAP. So all of those CoAP cases can easily be met by WebSockets. And then obviously we have TLS at the MTP layer, because if you're implementing those specs, then you already have it anyway. But also you can do it within a session context. So why would we do that? So when we built this, we knew that it was going to be deployed in a bunch of different inter-network situations. So we wanted to provide message integrity and encryption at the USB layer. Specifically when you're crossing message brokers or proxies or other network boundaries to protect against man-in-the-middle attacks and other things. And we use USB records to manage that session context. So all of the messages, including the record and the record and the messages, are both defined in Google protocol buffers. So if you're not familiar with Google protocol buffers, it's a mechanism by which you can write a really easy schema to define the structure of your messages. And it also allows for binary encoding on the wire, with a couple of exceptions for us because we do a lot of things with strings. But for the most part, it shrinks the size of the message, and it makes it so that when it gets to the other endpoint, the endpoint can just automatically understand what's going on without having to figure anything out. And it's also nice and extensible. So it's all based on the number. So if you happen to, you want to change the names of any of these things, it doesn't affect anything. And you can add new stuff to it very easily. So the USB record is specified in USB record.proto file. It basically has source and destination information. It provides information about the session context, if there is one, and tells you what security you're going to be using. It looks kind of like this. This is what one would look like without session context. This is sort of the simplest one, but you can see, and I say look like, but this is how we think of it, right? Because on the wire, it doesn't end up looking like this. And then the USB message is defined in a different proto file, USB message.proto, and that defines requests and responses, errors, and also the ability to use in certain contexts what we call allow partial and required parameters. And we define these things because the other power of USB is that it's very forgiving. So if you go to do something and there's an error, there's a very easy mechanism by which you can recover from those things and figure out what's going on. Or if you want to be fancy with what you're setting. So here, let me just do this really quick because this is an example of a message as opposed to the record, right? So this is like the add message and what you would see, and the add response. Again, it looks very much like the record, right? And this is just what you would end up using to translate to a human readable format, because on the wire it'd be totally different. And I want to talk about, I forgot these have some animations. I want to talk about that message flexibility. So we basically gave the ability to, if you're building a configuration, you can say, don't do this unless these required parameters are successful. And then also, you can, so let's say you're trying to do update multiple objects. You can say, look, I want you to do all of this or none of it. So if allow partial is false, you say, I don't want you to, don't do any of this if at least one object fails. And then the agent is like, well, one did, so it delivers an error back, right? And then if allow partial is true, you can say, do whatever you can. I don't care about which things fail, but keep doing things despite that. And then it says, oh, at least one object failed. I did the rest, but here's the one that did fail. And that's really nice because it allows the controller to be much more flexible in what it can do to the agent on the fly and for different use cases, right? So if you're trying to use it in the context of setting an entire state, you would use allow partial false. But if you just want to tweak some knobs and trust that it works, you would use allow partial true. It's good for the IoT use case. Some of the other mechanisms that are enabled by USB that are kind of out of band of the protocol itself, but not necessarily, is bulk data collection. And that's what we use for a lot of the network optimization and Wi-Fi stuff. So it's configured in the data model, right? There's a bunch of commands and parameters that you can set in the bulk data object, including the target, right? So for you can set it to be a different data collector that's outside the context of USB, right? So if you say, I want you to gather these things this frequently and report it in JSON format or CSV, and I just want you to send it over HTTP or MQTT and send it to this target, and then that data collector becomes its own thing doing its own thing. And like I said, it's very useful for mass telemetry, particularly for Wi-Fi. But let's talk about that for a minute. Wi-Fi is the biggest pain point. This is where a lot of these use cases have come from for the stuff that we built. And most recently in device 2.15, we've been working closely with the Wi-Fi Alliance to incorporate their data elements KPIs into the data model. So those things are now, you can now gather those diagnostics using USB through the TR181 data model and do this optimization using the USB ecosystem, which is really cool. And that was basically done through BBF and WFA through joint membership, going back and forth. And saying which things work, which things didn't work, well, what should we add, what should we not add. But it's been really cool that we were able to do that and get it up and running. I want to end with this, just so everybody can keep this in their minds as we have questions and stuff. This is kind of the big picture, like I said, so I'll leave this up while we're asking questions. But before I do that, I want to point you at a couple of resources. usp.technology has everything you need to know about this. And if you are looking for the open source agent, you can find it there. And then we also, if there's things that aren't being met by the data model or by the protocols that we're building and you want to have your input, we welcome all participants at the Broadband Forum. And in our group, we like to say it's the most fun you've ever had in standards, which is not a dig at the IETF. I'm sure it's very fun there. Our next meeting is a Q2 meeting, and that's going to be entirely virtual. All right.
That was awesome. Thank you, Jason.
There's a lot of talking.
So there is a question. It was posted before you actually got to those latter slides, but I'll ask it anyway. USP currently supports bulk data collection. Are there plans to support a real-time streaming bulk data collection from CPE to cloud? This would be a great enabler for Wi-Fi, AI/ML analytics, and troubleshooting insights.
I guess it really comes down to what the definition of a real-time streaming is, right? Because you can set bulk data collection to be pretty frequent if you want it to be, and you can also do it through a couple other mechanisms like periodic statistics, right? So we're actually working on maybe combining these two things. So if you don't necessarily want to use the bulk data collection mechanism, there's a couple other ways that you can gather that data. Setting up, I could definitely see a mechanism by which we could define a way of setting up a stream through the same mechanism. Right now, that's not the case, but it's definitely something to think about. I don't know, Barbara, did we ever talk about that?
I have to ask John. Anyway,
Yeah.
Nalini. Nalini has her hand raised. I'm going to let Nalini ask a question.
Yeah, thanks so much. This was a great presentation, Jason. Really thank you for doing this. My question really, so I'm trying to put all this in context for in the enterprise world. So do I have, and so I'm gonna take Mike's trademark and say I'm gonna ask you some dumb questions to put everything in context. Is like, so essentially we're talking about layer 2 is what we're talking about. That's where you're operating. And so, like, for example, if I had a TCP retransmission problem and I happened to know I was going over the Wi-Fi interface, I'd be like, okay, well, let me get me some data from your thing here and see what the problem is. Am I saying that correctly?
Oh, yes. So TR-181 has actually been around for quite a while, and the majority of the diagnostic information has been defined for quite a while. And so all of those kinds of metrics are in there. And so if you want to set it up in like a polling situation or using the bulk data mechanism or any of the USP's built-in notify mechanisms, or just having it trigger and be like, hey, I want to read this stuff right now. That's all in there and pretty easy to do.
Now, you also mentioned that there was the work with the Wi-Fi Alliance, where Wi-Fi Alliance identified a data model that it calls data elements. And a lot of the data elements is the retrieval of all sorts of parameters, not just from an access point, but from an entire multi-access point network, all of the things that they can report to one another at layer 1, at layer 2. And I think the data model, the TR-181 data model, has been extended to allow retrieval of all of those things.
No, that's great. What I'm going to do. Oh, yeah, go ahead, Barbara.
No, you go ahead, Nalini.
Sorry, I get all excited. So I'm gonna. Okay, so as I say, as you're talking, I'm just thinking back and thinking about like what our enterprises are doing. And I'm going to go back and ask some people, and we may even want to do a survey and then take some conversations offline, because I don't know how many enterprises you guys have. Yeah, well, I'll get to my question in a minute. Because I know that before, a lot of people used to use SNMP. It was brutal, it was painful, but it worked. Whether and how many folks have migrated to using even SNMP version 3, I believe that's the latest one. That was a pain in the neck, and I know a lot of people did not go. And I've kind of been out of that world a little bit. And I need to ask our enterprises, how many of them are actually using Yang models? And the other thing, I know some of the forward-thinking folks are talking about using, machine learning. And we're totally not there yet. But I'm going to go back and ask our folks, are they familiar with some of the stuff you're talking about? And as I said, this is in the dumb question territory, because I live in layer 3. I live above where you are, and I'm fascinated. I just don't know, so I'd be curious what your thoughts are, and Barbara too.
Well, so there were a couple slides that I originally was going to put in here to kind of set the context a little better. The reason why I talk about Wi-Fi as that bridge between worlds is because you have companies like Meraki, you have companies like Mist, which is Juniper Mist, and Cradlepoint, a couple other companies that are building these devices, building Wi-Fi gateways and Wi-Fi mesh systems for enterprises, but under the and they're giving you a cloud service that they've built that is their brand to manage these systems, and it's almost exclusively for the purpose of doing Wi-Fi. Like, they came in from the Wi-Fi world to do these things. They are all very fantastic solutions. They are proprietary. The things that USP does are the same. It works in the same space. From the enterprise perspective, it really works in the same space there. You can also see the use cases for managing firewalls, changing some things in real time there, gathering certain statistics from firewalls, and that stuff's already been defined and modeled and stuff like that. But that was sort of the original way that I was going to set the context here, is that you're in this weird world now where the dividing line is getting shifted, and as you get closer to things that are more like consumer electronics devices that are being put into the enterprise, you run up against this different management framework that isn't necessarily met by what SNMP and NetConf are supposed to do, right? And they're not supposed to do those things, and that's fine, because they're meant to be like, okay, we're pushing a giant network configuration. Here you go, But also from the cloud native perspective too, right? So, you have SNMP and NetConf, but then you also have you want to have enterprises that are spinning up virtual services, or interacting with their cloud networking services, and they're orchestrating that, on the fly, and having automated processes bring things up and spin things down, and making sure that the device management world plugs into that world is very important.
Sure, thanks. Barbara, did you have some thoughts? Yeah.
There was something else. Broadband Forum, I did want to also mention, also does some work on performance diagnostics definition. I mean, of course, Nalini, you're very familiar with IPPM in IETF, and Al Morton and the work he's been doing on performance metrics as it relates to capacity across the internet and things like that. And he's been taking a lot of that into Broadband Forum, and the data models for these diagnostics tests and things are defined fully in the TR-181. And if there's any diagnostics tests that are missing, that's where, back to some of the earlier discussion of get involved and make things more useful, it's actually really easy to ask for new parts of the data model to be created if there's anything missing. If there's management of a particular diagnostic technique that needs to be put in there, really the thing is ask for it. With that, I want to let Michael ask his question.
Yep.
Thank you,
Thanks,
Barbara. And yeah, I do have a question, but first I'm going to respond to a couple of things that Nalini was trying to shame me into saying, I'm sure. We're at Enterprises, we're almost exclusively SNMP. And a few years ago, quite a few, I think, I don't remember exactly, the security folks forced us to go to SNMP v3, which we did. There were some pretty inadequate security protections and precautions in the previous version. So that actually made sense. I didn't like it at the time, which you can probably sense. So that's kind of where we're at today. So finally, leading up to my question for Jason is that I don't think many of us are paying much attention to NetComp. And the question is, and then another IPv6 where now, why should we be? In other words, sort of what's the business case that we should make this conversion, because we're going to resist it like we do everything else that's new, even if it's way better. So anyway, and thank you in advance for your answer and a great presentation, Jason.
Thank you. So you're asking about for the people who haven't shifted to NetConf, why might they want to?
Right. Yeah. What's the motivation, so to speak?
So again, and this is in the context of the people who would already be meeting the same use case as SNMP, because there are still some use cases that NetConf defines that NetConf does not meet, and those are the ones that I was kind of talking about today. But in terms of the same use cases as SNMP, NetConf is just the protocol itself is a little bit more well defined, but also the data models are better, right? And the IETF has done a lot of work around these Yang data models and rebuilding things from the ground up and being like, okay, this is how we actually should have talked about this stuff. That's always a really hard convincing people to change is also really difficult. We run into that with TR69. There's still people out there's still deployments out there that, because they were based on that older TR98 standard and basically hardwired into the OSS and BSS systems, that there's still people who haven't changed over from that. But from the Yang perspective, they really took a step back and were like, okay, how can we get this to be better defined and work better? So I have a feeling that the same things that we run into when defining our newer data models in device 2 or TR181 were probably some of the same design decisions that the IETF did when they wanted to move to Yang. And that is, there's probably some technologies at this point that you can't manage in a standardized way using the older SNMP MIBs, especially how bloated the private branch got over time. I mean, I just remember working with SNMP myself, and there was almost no effort whatsoever for anyone to look at what the standardized MIBs were. They just went off and built their own thing every single time.
Yeah, that would be my number one comment of why to look towards Yang, is that the Yang community and the vendors participating there really have put an emphasis on developing the data models collaboratively, or the information models collaboratively, compared to spinning their own private branches to this. And that alone provides the portability that you would gain from Yang. And then you couple that as Yang, and then you kind of have the same option of transport or protocol between NetConf and RESTConf in how you're actually implementing that into your systems.
That's really helpful, guys. Thanks. One more DQ, if I can throw it in, and this is probably an unanswerable question, but any perspectives you might give. So most of us are going to be SNMP v3 converting to NetConf. How big of an effort is that? Is there any perspective you can give us on that?
So I am not a person that is that familiar with NetConf, because I don't necessarily have to work with it as much as I used to have to work with SNMP in the past. And the focus that I've had for the last 10, 15 years or so has really been around this side of it. It's so interesting how we're having the two worlds combined for a number of reasons. Number one is Wi-Fi. Number two is work from home. Number three is, SD-WAN in that whole situation. So I've come at it from the broadband CPE management and consumer device management world. If I had to give a quick answer off the top, off the cuff, it will be as difficult as it is embedded in your larger infrastructure. So that's really the situation that most people come with. What I don't know necessarily, and somebody else can maybe speak to this, is how backwards compatible the data model is, like those standardized MIBs that, again, S&P had standardized MIBs that different organizations had defined, right? Like even the ATM, there was the ATM forum or whatever back in the day that had defined standardized MIBs, but it was a question of whether or not people bothered to use them. But it's like Barbara and Lincoln said, the IETF now is doing a really good job with Yang in terms of making sure that is standardized. So as long as that backwards compatibility exists to some degree, then the migration is probably a little bit easier. As long as the same hooks, and that's why we reused our data models between Tier 69 and USPs, because we wanted to make sure that the same hooks that were in place on one device would still be able to be used with the newer technology.
Thanks for all that insight. You did answer the unanswerable question. Thanks so much.
It's you're as slow as your slowest moving piece, so it's like you have big operators out there that they've been using Tier 69 for so long that it's embedded in a lot of things. So the change will always be, however, as painful as it is to change those things. However, I will say that the change happens faster, at least we've seen, when there's a point where there's either some sort of killer application or killer technology that is only being defined in the new way, right? So for us in TR-181 and device 2, that was IPv6 initially, right? We're like, you know what? We're not putting IPv6 in the old data model. So if you want to do it, it's in the new one.
Okay, with that, Nalini, I'm going to ask you to hold your question, or maybe ask it in the chat, and we can answer it offline, because we are now at the time for our next presentation. Satish Jamadagni, I hope I said that right.
Yes.
And I think, let's see, we'll get the biography up. Here is Satish's biography, which I have to say I'm really impressed with. So you're currently Vice President and Head of Standards in Relicense Geo. And, I think anybody who's been around IETF and IPv6 is familiar with Reliance and just the amazing work they have done in being a leader in deploying IPv6 and in being a leader in the telecommunications marketplace in India. So I'm really glad to have you here. You're also active in a number of other organizations, TSDSI, previously a co-chair of the Asia Regional Operators Group, Small Cell Forum, which, hopefully you knew some of my friends from AT&T who were pretty active there. And then you've been on the board and that's a lot of patents. Let's just say that's a lot of patents, 200 granted patents. And so with that, Satish, let me ask you, would you like me to display your slides, or are you ready to display them?
I think I can do it myself, yes.
Okay, I will let you take it away then. I'm here to support you if you need me, though.
Sure. Can you see my screen, please?
Yes, and you can probably put it on the slide projection. Perfect.
Okay. So thank you, Barbara. I'll be talking about private networks today, and what are the blockers or what is enabling private networks today? Where is the interest coming from, and is it really a small phenomenon in certain niche areas, or does it have the potential to be a wider deployment use case going forward? So in order to understand private networks, if you can look at one of the so-called private 5G network deployment, this is done by Mercedes-Benz. And they've done it in one of their factories. And they have collaborated with an operator, Telefonica O2 in this case. So that there are a few things which comes out of this deployment. One is Mercedes-Benz wants total control of how things are deployed. That means even though it is so-called private network, the spectrum is coming from Telefonica. And I think even the equipment is coming from Telefonica. Within the way it is orchestrated in terms of the data collection, in terms of optimization objectives, in terms of which of the production lines need to be automated, all of this is done by Mercedes-Benz. So what that also means is, though you have a certain amount of 5G equipment put in for the data collection part, you will need to put together a lot of data crunching capabilities in the network. And this has to be done by Mercedes-Benz in terms of analytics tools, the application that has to be deployed, the specific verticals, and what makes sense, what doesn't make sense. All of this has to be decided by Mercedes-Benz. They are totally in control of this. And there's a lot of money that also has to be put in. So much of the heavy lifting is as much on the money front as much as it is on the engineering effort. So this is where it is right now. And this is more or less a case that you can see across more or less all of the private network deployments that you see today. Either in the mining area, you may come across quite a few of these deployments in the mining area. But essentially, the owner of the private network will have to do a lot of heavy lifting. So the key question is, will this be the norm for private network deployment? That means there's a lot of heavy lifting which has to be done by the individual deployment industry, or can it be commoditized? See, the interest is to primarily get it commoditized so that even medium or smaller enterprise networks can deploy private networks. That is the angle in which we look at it. Primarily because it enables a larger business use case scenario. And what will it still take to get it commoditized? So heavy lifting is all fine. A few companies in the world who can really put in the money and do the heavy lifting. But then the key question is, how do we commoditize this, or what are the aspects which come in the way of such commoditization? So one of the first things is, of course, the connectivity aspect. When we talk of connectivity aspect, this is the spectrum aspect. And the other one being, of course, the orchestration and the enablement of the particular verticals. That means you need to have some kind of a services layer in between, on which you can deploy some of the vertical specific applications. Or is it that very straightforward that you can just have any service layers today? We will look at it, of course. So looking at connectivity and spectrum issues, there is the CBRS in the US. There is a spectrum which is set aside by the government, which is to act as some kind of a common spectrum for deployment of not exactly private networks, but then again, of course, it's seen as one of the key enablers for private networks. And then you have that is one of the scenarios. If you don't want to use it, if you want to have a tighter control on the or reliability in terms of spectrum or in terms of connectivity, you need to lease it from one of the existing operators. and or you become something like an MVNO for MNO, mobile network operator. You're primarily acting as a subsidiary to one of the mobile network operators. So, and not very many spectrum sharing mechanisms are out there. Of course, CBRS is one of the models, and we've not seen CBRS deployments widely again so far. I mean, it's still very much in the very initial stages. We're yet to see a grand success story from a CBRS perspective. The other thing is, if connectivity is all that you're looking for, Wi-Fi 6, Wi-Fi 7, which is also coming up, is fairly good, and this has also been tested by the aerospace industry. And they're it's a published, well-known effort from the aerospace industry. It says that Wi-Fi 6 is really good in terms of the interference mitigation technology which has gone into the specification, and some of the KPIs which is demanding from an aerospace industry is met by Wi-Fi 6. That seems to be good enough. One does not necessarily have to. Then why does one necessarily have to look at LTE or 5G networks? Is one of the key questions that will have to be answered, and this will continue to be a key issue which will continue to exist sometime. Unless and until you want total control on your spectrum, you do have an option of Wi-Fi 6. I mean, that's the key message. And the other big part is, unlike Wi-Fi in 5G, you still have to own network. A network doesn't come cheap because there's new technology. It's not commoditized, so there's still a lot of IP cost associated with it, including manufacturing cost. And if you're looking at newer technologies like massive MIMO, those are, it does come at a cost. There's a cost associated with it. So that is where we are right now. 5G specifications do speak of edge capabilities, but then again, it's just some kind of an enablement capability. Is just a platform. The way the edge network or edge infrastructure is utilized within a private network or within an enterprise, there's still a lot of layers of application or service enablement that has to happen. I mean, it's just not straightforward for somebody to just come and plug in their web applications onto a edge infrastructure, specifically from a vertical perspective. So this is one of the key issues: spectrum issues, spectrum sharing, spectrum bartering, spectrum whatever. That is an issue that has to be addressed fully yet. Only few the reason why this is an issue is only few geographies has CBRS. US has CBRS, and EU you don't have anything. There is, of course, new spectrum which is getting auctioned, or at least being stated to be up for auction in geographies, specifically for private networks. But the definition of private network itself from a regulatory perspective is unclear. So there's a lot of regulatory aspect also which comes into the picture here. So that's where we are right now, the whole scene. What is 3GPP doing? They've defined something called as non-public networks. Then again, this is very rudimentary. I mean, it's nothing very deep. With the help of this picture, you can understand that you can always deploy a service which can be used in the enterprise scenario. And you can always have some kind of a handing over into a public network. So there is one model where you can have public and private network integration in some sense. The enterprises will have to take a call on where the integration happens and stuff. And you also have an independent private network deployment, which is a network in a box kind of a scenario where you own everything, only for maybe spectrum and whatever billing aspects associated with the spectrum goes into the main operator's network. But otherwise, it can be fairly independent. But then again, there are issues of where does the spectrum come from, and where does the affordability of boxes. These are still key issues. Handset is still a fairly commoditized segment. Price is not so much of an issue. I mean, you do have an option there. You have multiple options. The other part of the story is, of course, somebody puts in a network. But how does he connect much of the factory line into the network, into the connectivity system? And of course, you can always use the cloud as a common denominator where you gather the data. And subsequently, there's some intelligence in the cloud which uses the data in some way, but and feeds back into the machines. But then again, if you look at the flow shop today, if you just take one example of a flow shop, you will have a lot of proprietary technology from a lot of specialized companies. Robots from Germany, robots from Japan do not interact with each other. They do not even expose any of the functionalities, and they go through very proprietary software. So these are some of the issues which are yet to be addressed. There is still a huge gap in terms of the specification work which needs to get into this area. You do have a common API framework. What does this kind of a common API framework give you? Or there are multiple parties, multiple bodies which actually give you some kind of an API framework. But then what does the API framework give you? It's just a very rudimentary framework which gives you group management, some kind of an identification of the end devices which will not be managed. Configuration management, though, is used as a term here. When you speak of specific verticals, the definition of configuration management changes. If you're just talking about the management of the 5G network, the 4G network, which is deployed in a private mode, that's a different thing altogether. Even then, there are issues there because the way a macro network is orchestrated, configured, and managed is not specifically the way a private network will be managed. So there's a small subset of this functionality which will have to be carved out of an existing bigger software or ecosystem. And trust me, I mean, with experience, if I were to speak, it's not a very mature space. One will have to do a lot of heavy lifting, and a lot of software will have to be developed within the private organization. How many private organizations can really afford to do that? This is one of the key blockers in my view. Spectrum still can be addressed one way or the other, but that's some regulatory and other aspects can be brought in which can change the scenario on the spectrum side overnight. That is not necessarily true in the case of the so-called application platform or services platform, or a combination of the application and services platform which is needed to enable larger deployments of private networks. And this is where we are today currently. Or unless and until, of course, you do find a lot of examples which says the incumbent or the private enterprise is willing to do much of the heavy lifting in terms of the capex infusion, as well as the application and the overall utility that needs to be developed. That's a different thing altogether. Then is it a mass market phenomenon? Not yet, unless and until a small enterprise can just buy things off the shelf and switch it on and things work. It's still not there yet. You do have the recent announcement from Amazon. It says we have a cloud platform and you can just place an order for the access networks to primarily run. I don't want to get into that, but there's still a lot of issues associated with that. Then again, there's always the question of where do you get the spectrum from? If it works in CBRS also has issues. CBRS also has issues in the sense, for example, if the number of users go beyond 3 in a given area, you do have interference issues. There are other issues also with respect to, say, for example, what is the granularity of spectrum sharing that can be enabled by the CBRS system. And then again, if as long as it's just 1 or 2 enterprises, it's all fine. But if you try to make it a commodity, and that's where the money is. I mean, most operators are interested in this if it becomes a mass market phenomenon. But if it is a niche ecosystem, it's only a few players who do. But in the larger interest of the industry, it has to get fairly commoditized. For that, there's a substantial amount of standardization work that has to go in, primarily on the platforms, application, network configuration, orchestration, or as one would call it, a services layer plus an application ecosystem place. That's it. Thank you.
That was really interesting. I do appreciate that. I have to say, I've had some conversations with various people on exactly this topic lately. And so I'm really glad that you came in to talk to us about it. Do we have any questions from the audience about this? Nalini, your hand is raised.
No, of course it is. No, it's my goodness, this is just absolutely tremendous. So let me tell you kind of where I'm coming from too, and then you tell me what your thoughts are. So one of the reasons I know I was very excited about hearing this topic is that the use case I'm thinking of is for a lot of underserved communities, and even out like where we live. I live near Big Sur. You get past a certain point, ain't no cell service. You know, I mean, you just did, you know, for quite a while. And there's a problem because like there's fires down in Big Sur and people can't get emergency services. It's just terrible. And satellite is so expensive. I don't know what your thoughts are about this kind of use case. I know we've looked at a thing, but let me just stop talking now, see what your thoughts are.
Yes, the intention is to, if it is to serve connectivity issues in certain communities, yes, it is a viable solution today. You do have cost-effective solutions. I'm not even talking about the what is called as a D2D, direct-to-direct phone-to-phone connection. I'm talking about network infrastructure-based connectivity, but it's a local infrastructure, which works perfectly fine if you ask me.
You mean the private 5G? That's what you're
private
saying.
LTE or a private 5G network works perfectly fine as long as that community is willing to manage the entire ecosystem, the handset ecosystem, the SIM cards, the provisioning. You know, there's a lot of things which comes in along with that. So it's not.
No, that's the problem. All right, that's the problem. Thank you.
Lincoln, your hand is raised.
Yeah, so a very interesting presentation. I, think there's a lot of challenges that you've correctly identified in how do you manage a relatively complex infrastructure, from a private enterprise's perspective. I'm curious if you have any opinions on some of the activities that we see in the world with, the collaboration that's starting to happen around, open source and open hardware, specifically in 5G, you see organizations like Open RAN or ORAN kind of trying to come in and provide a means to develop the hardware and the software components and make those available, kind of outside of their traditionally scoped suppliers or supply chains.
So Open RAN has primarily two objectives. One is, of course, to bring in a lot of interoperability specification. There is the O-RAN Alliance, which is trying to do that. And there's another Open RAN Alliance, which is trying to bring in a larger ecosystem of chipsets. Today, everything was closed. You have a very few number of chipset vendors. But they're trying to bring in a more number of chipset vendors. So you can have the ecosystem in place. You can bring the price down. These are the two objectives of Open RAN. That plays very well into the private network scenario. For the LTE, if you look at the LTE scenario, you never had a chipset on which you could build a LTE base station available. They were all privately held. Nokia had their own chipsets, Ericsson had their own chipsets, Samsung had their own chipsets. It's only later on that FPGA was played around. Now you have a lot of these ASICs which are coming in from Xilinx, NXP, MaxLinear, Marvell, ADI has their own chip. It's really catering into the overall cost ecosystem, and it's playing out perfectly well as far as the private networks are concerned. But the big ticket item still is the spectrum. unless and until CBRS is one example, which is an exception. But apart from that, if you look at the rest of the world, it's spectrum is still an issue, which is the operators pay very large amounts of money for the spectrum, billions of dollars. And it's not going to come in cheap for the private network enterprises. And even if there is a leasing or whatever other specification which comes into the picture, apart from CBRS, I believe personally that there is still a need for a standardization activity to strongly influence uh, what would you call as democratization of spectrum or some kind of a fair share of spectrum and some such thing. You still have the spectrum issue that has to be resolved, even if the cost of the 5G equipment comes down. But today, the cost of 5G equipment is not less. Even though these new chipsets are coming, we are yet to go there. The chipsets are coming. The ecosystem is headed in a direction where the cost reductions are showing up. But we are not fully there. And as far as the other aspect of interoperability is concerned, I wouldn't want to comment on that, but it's the promise of ORAN has not necessarily been very encouraging on that front. Yeah. So, for example, when I say that you buy a piece of Nokia equipment, you buy a piece of Samsung equipment, they may not work. They may not interwork to the optimal KPIs set out. That's where we are right now.
Cool. Are there any other questions? I'm not seeing any. And so if it's okay, I think we'll go ahead and start our closing and general discussion. And we'd love for you to stick around because questions always happen and you may have some of your own. You know, I just want to go back to look at what we talked about today, which is, you know, how can enterprises and even beyond enterprises get involved in standards activities? And we've discussed this kind of heavily today. And certainly in organizations like IETF, it gets really easy because they do work so hard to allow for free attendance and remote attendance at their hybrid meetings, I guess they're calling them now, no longer face-to-face, even though there's a face-to-face component. They're also trying much harder to allow for the remote attendance experience to be good. You've also had an invitation, you know, from Broadband Forum to ask to be a guest at one of the meetings. You know, certainly that is a slightly more closed environment. Something else, you know, since INTC does have its webinar series going year long, some of the topics that I would like to address, you know, I'd really like to see if we can have even more in-depth conversation around what we can do to better secure, improve firewalls, secure the network in the face of all the traffic going across it is encrypted, even the DNS traffic. I'd like to also try to invite CTA to talk about their IoT device security. They wrote a specification for securing IoT devices, and they've also been working with various organizations for doing a certification of IoT security, and I think that would be a really interesting topic beyond IETF. If there are any additional topics that people would like to see have discussed within any of the ongoing webinars from INTC, we'd love to hear from you. Membership in INTC is free. I think Dhruv will be posting those links for both IIESOC and INTC again, or someone will. But kind of in general, I'd like to get a feel from some of the attendees, if any of you do have thoughts on what would you like to hear about. And it can be IETF, it can be beyond IETF. What are the conversations you'd like to have? I don't know if anybody wants to speak up on this, because this now is an answer not to our panelists, but really to our audience of what do you want to hear more of And, you know, we've heard from a number of internet legends as to what keeps them up at night, but I'm curious from the audience, what keeps you up at night? So let me just open it up. And if nobody wants to talk right now and you want to mull this over, do think about it, do reach out to us. And, you know, I just want to then take a holistic look at this week. We've had some really interesting topics. We have discussed what keeps us up at night. We've discussed certainly the extension headers, which I really appreciate the polite discussion that happened here. For those of you who haven't seen the conversations that historically happened at IETF, it was not pretty to watch. And yes, standards activities can sometimes be very emotionally difficult. Jason, is there something you'd like to bring in? No, you just sort of popped up. I don't know. And we've had the discussion on IoT. There was some interesting work presented about, I believe, an online course that would be offered around a lot of the IETF activities. And with that, I think that's sort of all that I have to say. You know, again, we encourage you to join these organizations. The links have been posted. And I think maybe I'd like to turn it over to Nalini and Dhruv to further close up this entire week.
Thank you so much, Barbara. And yes, so if I think Mohit is bringing up the session. This was just tremendous, and I have there's so many things that I'm thinking about from what has happened this week. And one of the things it just occurred to me is I just wonder if like IPv6 is going to be the reason that we move to NetConf. I would be real interested in how much IPv6 support there is of SNMP. But anyway, that's just a thought. And one of the things that we've done all along quite successfully is to have some of Mohit, whom you saw in the beginning. He's a professor at NITK, and we've had a number of his students do various things, including co-author drafts. We can set up some kind of environments for some of these things, because to have some hands-on experience with a lot of what you've talked about, I think would just make it much more alive for everyone. But let me close out by thanking everyone. This has just been just a pleasure to be a part of, and the speakers, panelists, and all the participation is really what makes it happen. Next slide, please. Thanks again to all our sponsors. We really, really appreciate you know, everybody who has backed us throughout the years. And you know, one note about APNIC, you know, as I say, it occurs to me that APNIC also has quite a few grants that they give, and some of the issues that were brought up on the power consumption and even the private 5G. There's some excellent grantees from the APNIC ISIF Foundation. For example, one group is putting up bamboo cell phone towers in India. The reason I bring some of this up is even from the IoT panel is like the issue of power source for our farmers in India, and the issues they're dealing with are quite similar to what we're seeing in Africa. And so I really think, and actually throughout the APNIC region. And so I think there's a lot of cross-pollination and presentations that we can do. We can maybe bring in some of these folks who are grantees of APNIC, because I say that may really resonate, and then maybe bring them over into the IETF. or Broadband Forum now, now that we're aware of everybody. Yes, next slide, please. And so, guys, please become members. And I am going to say we get notified every time people become members. And I'm going to say just during the course of this entire set of presentations, there have been quite a few people who have signed up. Please do become members. There's a vote for the board going on right now, and we'd love to have you work with us. We have an enterprise advisory council at INTC. If you would like to participate in that, we'd love to have you. Michael is the chair of that, and you can talk to us about that. And in IISOC, we do a huge amount of work with IPv6 deployment, and that is just growing tremendously. We've had ISOC, Hyderabad, IEEE, Chennai wanting to participate in some of this. So this is all great. And then, guys, you know, one of the things I'm really excited about is the possibility of IETF in India. I don't want to think about that too much, but I'd love for India to be on the rotation for IETF. And you know, I think if we all work together, keep participating, that kind of stuff can happen. So please join us. And this is, as I say, this is a total grassroots effort, and on both sides. And so become a blade of grass. Next slide, please. So I hope you enjoyed everything, and thank you all so much for your participation. And please respond to our survey, and please reach out to any of us at any time if you have questions. And look forward to seeing you next time. There will be recordings of everything, all the presentations. Everything's available on YouTube as well. And so thanks again, and hope to see you next year and at our other webinars.
Thank you.
Bye.
Thank you, Nalini.
See ya. Bye.
Bye-bye, everyone.